Yeah. Sorry, guys. Are you able to see my PPT? Because I you unmute, I talk. I was talking, and then only you didn't reply. Okay. Sorry. Are you able to see the PPT? Hello. Someone reflect. Are you able to see the PPT or not?
Yes, sir.
Okay. Thank you. Okay. Now. Hello. Yeah. Just we recap what we discussed in the last class, then we go to today's class. Actually, what we discussed in the last class, we discussed rolling contact bearing. In the rolling contact, sliding contact bearing we discussed in the last class, right? Then what is the use of bearings and its applications we discussed in the last class, right? Sliding contact bearings, we discussed the type of bearings: journal bearing, footstep bearing, collar bearing, multi-step collar bearings. We discussed, right? Then we discussed that this is a types of bearing we discussed, and based on loading condition, radial bearing, and thrust bearing, and combined radial and thrust bearing types of bearings we discussed. Then later the bearing, the bearing comp item, the bearing, what are the components? One is, journal, bush, and oil flow line, and casings, split type, non-split type. We discussed in the earlier class, right? Now, okay. Is it video is recording or not? Hello? Hey, someone reply, whenever I'm asking simple question.
Sir, it's not recording, sir.
It's
No,
showing
sir.
me, it's showing me recording. Okay, anyway, I do it again. Now I'm checking some problem. Now corrected. Yeah. So that's what we discussed. The last class we discussed. We are now just a recap about whatever we discussed in the last chapter. Sliding contact bearing. Right? Just now I have been told you that what are the types of sliding contact bearing and the sliding contact bearing components we discuss. And the sliding contact bearings based on the load conditions, radial load, axial load, and both combined radial and axial load we discuss. And especially we discuss film, here the bearing sliding contact bearing, then inner side is journal or short. We have been already discussed about the shocked with respect to radial load, with respect to thrust load, right? In the first chapter. Then designing the shaft doesn't matter, but now the shaft early we whatever we discuss that time the shaft it's not involved into lubrication now, but when we discuss in the last chapter the bearing is subjected the bearing is acting as a support as well as it will allow the free rotation of the two relative mechanical components, right? Either shaft, for example shaft, the shaft should be and the bearing should be supported to the shaft. Simultaneously it allow the free rotation inside the bearing. Then we would like to introduce, then we have to apply this appropriate lubricant. Then only we able to obtain the appropriate relative motion between two mechanical components. That's what we discussed. Then when we are introducing the fluid as a lubricant, then the lubricant it makes the film thickness, right? Inside the bearing, the film that the film thickness is going to be generated between the journal and the bearing. That film thickness we discussed the boundary layer thin film and a thick film like that, right? In the thick film is hydrodynamic lubrication we concentrated mostly, right? Now thin film lubrication is under like metal to metal contact or maybe a boundary contact film thickness we discussed. Now, in the later we discussed that Patraf's equation, then the coefficient of friction, how it will be generated between the bearing and the journal surface, right? At the inner bearing surface and the journal, soft surface. Based on that, we discussed the coefficient of friction, using Patraf's concept. Then later we came to know that now that later we studied the hydrodynamic lubrication behavior in we studied, we discussed and we derived the hydrodynamic lubrication behavior in the form of partial differential equation. Who developed this concept? The Reynolds equation. The guy who developed this hydrodynamic behavior, he derived in the form of partial differential equation, right? But partial before in that, we also discussed the bearing characteristic number, a Mecky's equation. Mecky's defined that when the bearing is during starting, the starting condition, the bearing will be a rest. During first rest condition, the bearing and journals or bearing and the journal surface are in metal to metal contact. When the inside the journal speed increases, then wedge shape clearance is going to be generated slowly. Then we discussed that the critical modulus number K, right? Bearing modulus number K, we did bearing modulus, critical bearing modulus we discussed. And after certain speed, the wedge shape clearance going to be created between the bearing and the surface. Now, I'm sorry, I would like to just we go just 2 to 5 minutes for we spend some 5 minutes for recollecting the information. Okay, then we go to this topic. Now, 1 minute, I come. Because I would like to tell one more information. So that day I forgot that. So I want to convey that information also. So that's what today I'm doing recap, right? Okay. Now, yeah. Now, are we able to see now? Now later we discuss the bearing characteristic number. Bearing characteristic number we discussed and bearing modulus we discussed. Late after that only we discussed the Reynolds equation. Reynolds equation is just now I told you that. You would like to study the hydrodynamic lubrication behavior. Hence, Reynolds derived that in the form of partial differential equations, right? But that partial differential equation, whatever he developed, that is not given the full correct analytical solution. Because every research is like that only. If tomorrow you are going to start a new development, You may not you may complete or you may not complete for your tenure. Then your research, you are forming the outline of this problem. Then another guy, Raimondi and Boyd came to picture, and Sommerfield number came to picture. Then whatever the Reynolds equation developed, because we didn't use the Reynolds equation in our problem directly. That's what you may, some students may think about that, why we studied Reynolds equation, because the Reynolds equation finally we derived in the form of partial differential equation. That partial differential equations later, I mean the Raimondi and Boyd and Sommerfield, they, they solved that partial differential equation. Who developed, I mean Reynolds who developed the partial differential equation in the form of hydrodynamic behavior. These guys, Raimondi and Boyd, solved that problem, solved that equation using iterative method with the help of the computer. Okay. Then they obtained the solution. Attained the solutions, verified with the practical conditions. Then they made in the form of tabular values. The tabular values later accepted by the international research community, especially bearings related international research community, they accepted. Then we used, still we are using that table in our bearing design. Okay. Now that's what I mean, bearing design. So in the table, how to use the table to define our journal radius and oil film thickness, minimum oil film thickness, coefficient of friction variable, flow variable, and pressure ratio, right? Those things we discussed. Now we need at least two parameter. One is length to diameter ratio of the length to diameter of the journal. The ratio of the journal diameter, length to diameter, very important. I mean, another, this is very important. After that, we need any one of the value. Maybe if you know coefficient of friction variable or flow variable or Sommerfield number or, I mean, minimum film thickness variable. If anyone know, I mean, standard L by D ratio is very important. After that, any one of the known variable, then you can easily access the table for our solve our solve the bearing problem, or else to design the bearing. These are the important parameters. Okay. So based on the table values, we are solving or designing the bearings dimensions. Okay. Now, and that's what we discussed. Now later we discussed lubricant oils. Please, as a mechanical engineer, you should know what is SAE 30, SAE 10, SAE 20. I mean, that is, the SAE 30, the table actually I have given in the assignment questions, right? SAE 30, SAE 40 is nothing but whatever the viscosity of oil measured using Seybold universal second, that value divided by 2, approximately it will give you that. For example, Seybold viscometer some 115 or 110, then our viscosity range, we are referring that SAE, this is belongs to SAE 50. I mean, this is some approximately divided by 2. I mean, then we are considering SAE 50 like that, right? Now, this is at which temperature? At 212 degree Fahrenheit. Now, SAE 10, SAE 20, SAE 70, up to these measured at high temperature. I mean, especially 21 degree Fahrenheit we discussed in the last class. Also, what is SAE 10W? SAE 10W, as a mechanical engineer, you should know that this is at low temperature, especially in winter season. We are, for winter season, we are, we are in safe place. Our temperature is always more than 20 degree, right? But if you go somewhere north side, even some countries, the temperature is very less. Hence, the international research community, especially bearing research community, they develop. Especially this community means Society of Automotive Engineers. They developed and they put a new notation SAE 10W for low temperature oil specification, viscosity specification. So we discussed up to this. Now the one more thing that that day I forgot to tell. Now this is the problem. I mean, the last problem we discussed very nice, no doubt at all, this problem, because here I would like to tell one more information, because some students they may have some, I mean, doubt in this. See here, here the Reynolds, here, sorry, here our Sommerfield number in this problem is the 0.4608. 0.4608. This is the 0.4608 is, I mean, in between this value 0.631 or 0.264, in between somewhere, that we can't say exactly middle value. I mean, in this range, in this value, in this range only. Hence, we are taking these two values to find out our correct Sommerfeld number using linear interpolation technique. But in the earlier problem, I come to the my suggestion here. In the earlier problem, before this problem, we discussed one problem, that is, yeah. Now, yeah, in this problem, this is what we used in the problem 16.13. We used this interpolation technique, but the problem 16.12, see here, we didn't use any interpolation technique here, because the given value, I mean, already we know L by D ratio 1, okay, but the H naught by C ratio is, even the problem is a 0.3. See, the minimum oil film thickness variable is a 0.3. Hence, see here, the 0.3 where it is, the minimum film thickness variable 0.3 is where it is from. I mean, between these two value, 0.4 and 0.2 only, exactly middle value. 0.4 and 0.4 and 0.2 here. This is the minimum film thickness variable is lying exactly middle of these two value. Hence, we didn't go for interpolation technique. Similarly, we are taking corresponding to 0.121 and 0.2 corresponding to value Sommerfeld number 0.0446. Then 0.0446 plus 0.121 divided by 2. Hence, we directly use this average. Hence, that, I mean, we have been used directly average value. Then we have found that Sommerfeld number is 0.0828, because this is exactly middle value between 0.4 and 0.2. Okay, so that's what we didn't use here, interpolation technique. Suppose, suppose for example, another example. Now the Sommerfeld number is lying between, I mean, now the Sommerfeld number is given zero point 0.7. Then 0.7 means 0.8 plus 0.6 divided by 2, 1.4 divided by 2, 0.7. Hence, similarly, in this case, we can take our Sommerfeld number 1.33 plus 0.631 divided by 2. We can take average value. That's all. This is the things I missed out. So please understand, if you have any confusion, please overcome in that. This is important problem. Okay. Now I come to this today. Whatever we discussed, I mean, whatever we planned in the last class, we execute today. We are going to now rolling contact bearing. Okay. Are you clear? Any doubt, please, in the sliding contact bearing? Guys, please.
Clear, sir.
Okay. If it is not at all. Yeah, please give me a minute. Now this is opening. It's not open. Yeah. Now, are you able to see my roller contact bearing slides? Yeah, please. Are you able to see this slide? Guys, yeah, please someone reflect.
Yes, sir. Yes, sir.
Now we discussed we completed the sliding contact bearings. There are majorly two types of bearings. One is rolling contact bearing, another one is sliding contact bearing. So now, just now we go through that. I mean, maybe next 3 to 4 lecture we are going to discuss. For our lecture, we are going to discuss only rolling contact bearing. So now I come to the rolling contact bearings. Before that, I would like to ask you one question, very basic questions. What is a bearing, please? Someone reflect. Very simple question I am asking that. Because one-way communication not at all good. Please, someone reflect. What is bearing? First, come forward, someone, please. What is bearing? Otherwise, I will call the name.
Element able to give some relative motion between two rotating objects.
Thank you, Pa. Thank you. What's your name?
Pavan, sir.
Rogan.
Pavan, sir.
Okay, okay. Thank you. Okay. See, I mean, very simple question. Just now I told you that because I would like to ensure students are there or not in the meeting. Okay. Okay. Now see, I mean, what I told you, bearing is simple. That whatever he told is absolutely correct. Bearing is a mechanical components that permits the relative motion between any two mechanical parts. That's what bearing, right? Then bearing is, I mean, it should be a minimum friction to be maintained when the mechanical parts are rotating, right? Relative. Hence, the minimum friction to be maintained are followed while the two mechanical components are rotating. I mean, while the mechanical components is rotating with respect to other, right? I mean, what is the general use of bearing? It's able to allow the rotation of the mechanical component, for example, shock. Also, simultaneously support them. Simultaneously support the system, right? And this is a primary thing. Then, while transmitting the power in the form of rotation, it should be absorb the vibration and make the smooth operation without noise. That's what we are using appropriate lubricant. Lubricant. So that lubricant, I mean, we discussed in the last class. Okay, anyway, just recap. Similarly, we are going to use this, similar lubricant we are going to use in this bearing also, in this bearing. And we also discussed sliding contact bearing, where it is applications. We discussed in the application in marine engines, in IC engines we discussed, right? The sliding movement in the pistons inside the cylinder is sliding contact bearing. I told you some example also. In the sliding contact bearing, we are using this oil, I mean appropriate percentage of oil for 50 ml of lubricant oil along with 1 liter of petrol. Example we discussed about this TVS XL or TVS 50. I mean TVS power port. That those vessels now they stopped it. It's directly mixing the lubricant fluid with the petrol fuel. Okay, for performing the, free rotation, free movement, sliding motion of the piston inside the cylinder. Okay, that's what. I mean, bearing withstand the load. The bearing withstand the load which is acting on the support. See here, this figure is defining entire our DTE. design of transmission element, right? Early we discussed shaft, then we discussed gears, then we discussed couplings, how to couple the gears. We used the keys here, we used the keys, right? Sorry. Uh, we used the keys and we used the gears, we used the pulleys, right? We discussed correspond last in the last three chapters. We discussed shaft. First, we should discuss shaft. Then we used to, we discussed about couplings. Couplings use the keys. Without keys, you cannot couple the component. We cannot transmit the power from shaft to gears or shaft to pulleys. Hence, then later chapter we discuss sliding contact bearing. Now see here. Now we are discussing here. Rolling contact bearing. Rolling contact bearing. Now, now sliding contact bearing. Now the bearing is acting as a support and bearing acting as a. It will be a. It will allow to free rotation of the component, shaft component, while transmitting the power. Maybe this gear may be connected into motor, this gear may be connected to some other mechanism. Hence, during the time this gear may be connected to motor, the power is a transmitter, then this will be acting as a two support. This is called bearing. This is acting as a support, also called bearing. So here we are using, we may use, here we are using here rolling contact bearing. See here, this type of bearing. Now, that's what the bearing withstand the load which load is acting on the support. It may be vertical load, it may be tangential load, right? The load may be a perpendicular to the axis of the shaft. The load may be a tangential to the shaft, tangential direction to the shaft, right? Now the bearing is permits the rotation as well as a rigid support, as well as rigid support and hold the shaft securely. So now in this, these are the things very, the basic concept where we are using. Now once we are understanding, then you can easily getting motivation to learn the subject. Okay. Now I come to this. Due to the friction effect, we can say that due to the friction effect, we are classifying the bearing types. One is sliding contact bearing, rolling contact bearing. In the sliding contact bearing, we can say that plain bearing, journal bearing, or sleeve bearing. We can say journal bearing or sleeve bearing also same. Okay. Based on lubrication thickness, the bearing can be designed. Based on lubrication thickness, the bearing can be bearing can be designed. Also, the fluid, the lubricant fluid also can be decided which type of fluid we can go for particular application. Okay, that's what we discussed. SAE 30, SAE 10, SAE 40. Some oils we can use for two-stroke engine. Sorry, two-wheelers, especially scooters and mopeds we discussed in the last class. Based on our application, we have to choose appropriate oil, lubricant oil. Okay. Now, this is the things we discussed. And the rolling contact bearing, also called anti-friction bearing or ball bearing. The rolling contact bearing also called anti-friction bearing or ball bearing. Now, what is the function? Some of the function we discussed, then we go to deeply enter into the rolling contact bearing discussion. Okay. See here, the bearing ensures the free rotation of the shaft or axial, axial with the minimum friction. Now I am talking about the some of the points from our Bandari book only. I have taken from that. Okay, I have noted down and I have taken the hints. I am telling that. Okay. Now the bearings support the shaft, axial, and hold them at a correct position. Okay. Also, the bearing takes up the force that acts the shaft or axial and transmit them from one place to another place. Okay, these are the things. Now, the sliding contact bearing is also called plain bearing or journal bearing or sleeve bearing. Our rolling contact bearing also called, I mean, this is the anti-friction bearing or ball bearing. Ball bearing. Now, based on this, now I come to this. What is the application in sliding contact bearings? We discussed the crankshaft in petrol or diesel engine, centrifugal pumps, and I mean steam and gas turbines. Okay. Now rolling contact bearings. What is the where we are using rolling contact bearing? It's especially in machine tools. Okay. I mean automobile front and rear axle. We are using rolling contact bearing in automobile our vehicles front and rear axle we are using. In gearbox we are using rolling contact bearing. Okay, and we are using for crane hooks and rope drives. Okay, and hosting drums many place, not limited. I will show you, I will share you some videos. You go through videos, you can understand more in applications. Okay, how these bearings we are using in more applications, you can understand. Now, see here the construction of the ball bearing or rolling bearing or anti-friction bearing. This is the we have to understand the terminology. What are the terminology or notations we are using to identify the components in the rolling contact bearing system. Now, this is the width of the bearing. This is the outer corner radius. Outer corner radius. Now, this is a shoulder. This is a shoulder. Now, this is inner corner radius. This is inner corner flat. This inner corner, this outer corner radius. This is inner corner radius. This is the shoulder. This is the outer ring. This is the inner ring. Now, this is a bore. This is the near. I mean, this is a bore is close to our. I mean, equal to our shaft diameter. Now the shaft is going to be inserted in this region only. Okay, inner bore diameter is equal to shaft diameter. Now inner ball race. This is very important. Inner ball race. This is inner ball race where the ball bottom side is sitting. Inner ball race. This is the outer ring ball race where this curved surface the ball is sitting. Okay, now this is the separator or retainer. This is separator or retainer. Now this is the face of the bearing. This is the face of the bearing. This is the inner ball race. Because why I'm again repeating this, based on this dimension only, some of the bearing types we are going to discuss in later. Now this is the outer diameter. Now I'm asking one general question. I mean, as a mechanical engineer, you must understand this. What is the use of separator or retainer? Please tell me that, because this this geometry here. Now, I mean, here this one. What is the separator and retainer? What is the use of separator and retainer here?
Sir, it
Try to
prevents
indicate.
the sliding of the ball.
Yes. Yeah. 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 Continue. You are correct only. To prevent this sliding
Yes,
of balls, right?
yes, sir.
Why? Okay, why? Yeah, thank you. At least you are thinking and saying some answer. Please, correct only. Okay, again, further, any answer, further, any points?
Prevent the orientation from the ring race.
Yes,
The
prevent the orientation. Another thing, when the separator we are not using, the each balls are going to be touch each other. It will generate more heat. Then the ball may try to failure, right? Then we would like to avoid such a kind of issues. Hence, we are using separator. Your all answers are correct, but I have been added one more key points. That's all. Hence, we are using separator or retainer. Now, earlier case we discussed sliding contact bearings. I mean, here the balls, I mean, any spherical ball, it will be a line, it will be a point contact. It won't be, I mean, it mostly this, I mean, ball bearings, it's a point contact. But in sliding bearing, surface contact. In roller bearing, it will be a line contact. So one by one, we discussed all the things now I mean, that's what this is the things already we have been discussed. I mean, the lubrication used, why we are using lubrication. Lubrication used to separate the journal and bearing is usually mineral oil or refined mineral oil from refined petroleum. But vegetable oils also we can use as a lubricant oil. Similarly, the same lubricants is we can use in our rolling contact bearing also. Okay. I mean, this is the things already we have been discussed. Now I come to this. I mean, bearings broadly classified into two types: radial bearing and the thrust bearing. Then combination of this also we discussed. This is the bear load is perpendicular to the axis of the journal or shaft. Here the load is parallel to the axis of the shaft or journal. So based on that, we are saying that bearing in two types. I mean, based on load condition, we are saying that the another type is both load, combined load. Okay. Now I come to this. There are at least 6 common types of bearings, each which operates at different principles. Okay. Now one by one we are going to discuss later. Okay. First we see the outline of this. Okay. First, the plain bearing consists of shaft hole. Whatever we discussed, journal bearing. Plain bearing consists of shaft rotating in the hole. Here there's several specific tires, specific styles: bushing, journal bearing, sleeve bearing, and refill bearing. These are under sliding contact bearing. Rolling contact bearing, rolling element bearing, in which the rolling elements are placed between the turning and moving stationary races, prevent the sliding friction. Here no sliding friction. Here turning. This is the, this is the things going to be fixed. For example, this bearing is now we can use here. This is the things going to be fixed. This is the things going to be connected with the shaft. Then this is a moving element. This is the balls also moving element, but this is a fixed element. That's what we are saying here. Okay. I mean, when the rolling elements are placed between the turning and moving and stationary races, we discuss about inner race and outer race. Outer race component is fixed on the support, but inner race is fixed on the shaft. Hence, the inner race is rotating component, moving component. Okay. Now, there are two main types in the ball bearing. In the rolling bearing, in the rolling contact bearing, there are two types under the rolling contact bearing. One is ball bearing, one is roller bearing. In the ball bearing, we are using spherical balls, whatever we have been seen that earlier figure. The roller contact bearing, roller bearing, we are going to use a cylindrical or taper or spherical rollers. We will see that how it is this design, how it is this parts. We will see that later. Now the next one is the jewel bearing, the plain bearing in which one of the bearing surface is made of an ultra hard glassy jewel. Sorry, ultra hot glassy jewel material such as sapphire to reduce the friction and wear. Okay. Fluid bearing, it's a non-contact bearing in which the load is supported by a gas or liquid. For example, a air bearing. I will show you one video. You can understand the fluid bearing and magnetic bearing. It's a nice video. I have seen the YouTube. I will share you. We can see in this. Now itself. Okay, no problem. Of the end of the class, we will see that. Magnetic bearing, the load is supported by the magnetic field. Here, the fluid bearing, the load is supported by the gas or liquid, high pressure gas or liquid. Okay. Now, in the, flexure bearing, in which the motion is supported the load element, which the bends. Anyway, we are going to talk about only this bearing, rolling contact bearing only. Just you have to understand what is this magnetic bearing and dual, fluid bearing. Those things just you have to understand. Now, this is the rolling contact bearing. Just now we have seen this. The radial load is acting here. This is the rolling. This is the fixed element. This is the our rolling element. This is our rolling element. Now this is also rolling along with this shaft. So where we are using, just now I told you that this is for example, for recap the information I have put here, the sliding contact bearing, the difference between sliding contact bearing. I have put it here. So there's some figure. Okay. Now I come to the types of rolling contact bearings. The first one is deep groove bearing. We will see what it is. The second one is cylindrical roller bearing. The third one is, angular contact bearing. This is a deep groove bearing. This is A. This is a deep groove bearing. Okay. Now this is a cylindrical roller bearing. This is B. Angular contact bearing. This is C. See here, this is angle, this is inner side. This is some angle. Inclined surface is there. This inclined surface is there. This angular contact bearing. One by one, see you later. This is the self-aligning bearing. The third one. Okay. Self-aligning bearing. Now, fourth one is self-aligning bearing D. Now, fifth one is spherical roller bearing. This is spherical roller bearing E. Okay. Now, taper roller bearing. This is taper roller bearing F. Okay. This is thrust ball bearing. Thrust ball bearing G. Thrust ball bearing G. Now, this is looks like, one by one we discuss now. Briefly, we are going to discuss. This is a type of ball bearing, types of roller contact bearings. Now, one by one we discuss now. Now, first we consider that deep groove ball bearing. Okay. Now, deep groove ball bearing here most frequently used bearing in our mechanical applications, the deep groove ball bearing. Okay. And here, the deep groove ball bearing. Now, the ball radius, just please, you go through later this point by point I have been given here, so you can understand easily. Just we can briefly discuss this. In this deep groove ball bearing, ball radius less than the radius of curvature of the grooves in the races. In the races, in that sense, here, where is the races now? This is the inner race. Okay. Anyway, I go back because once, so if I show you multiple times, you can understand that construction. This is inner race. The inner race, the outer race. This is inner race. This is outer race. Here the ball radius. This is a ball. This is the ball radius less than the radii of the outer and the inner races. Okay, that is deep groove ball bearing. In this deep groove ball bearing, now no sliding, only allowed free rotation. Only allowed free rotation. See here, the deep groove ball bearing has a high load carrying capacity. Here this the high load carrying capacity. Anyway, I come to advantages later. Here this is a no sliding. Only rolling action is allowed. This gives the point contact. This gives the point contact between the gives the point contact between the in two races, outer race and the inner race. Okay. Now, where we are using now this bearing we are using for high load carrying capacity. Okay, we are using high load carrying capacity. We are using. This bearing can be used for takes wherever the radial and axial load, the transmission, that place we are using. Okay, the point contact between the point contact here, the point contact between the balls and races, the point contact between the balls and races, hence the frictional loss will be the friction loss and temperature rise will be less. Hence, this friction loss and temperature will be less due to point contact. Hence, this type of bearing can be used for high speed rotation. High speed rotation. These are these 3 points. You can go through your book, you can get it more informations. Some important advantages only I'm telling here. And this is the the disadvantages is the non-self-aligning bearing. Non-self-aligning bearing, it cannot be a self-aligned, and it's a poor rigidity compared with the roller bearing. This bearing, poor rigidity. Now we are talking about this bearing. This is a poor rigidity compared to the roller bearing. This bearing, this one. Now poor rigidity compared with the roller bearing. Okay. Now I come to the second bearing. Now this is a cylindrical bearing. In the cylindrical bearing, using short rollers. In the cylindrical roller bearing, we are using short rollers. See here, instead of ball, the ball is replaced in the form of short rollers here. In here we used some retainers, but here we are using here some cages. Cages, cages, cages. The cages, I mean, act as a guide to the rollers. Act as a guiding, I mean, it will be guiding the rollers. Okay, now this is the very important difference. That's one. I mean, remaining things are same. Here also inner race, outer race, and this is the inner. I mean, inner corner radius, outer corner radius. Those things are same. The main difference only we are discussing now. The dimension and design main difference. Now, what is the advantages of this roller bearing? Now, I mean the contact rollers, contact between the rollers and the race, contact between the rollers and races or slide. I mean here this is the line contact. This is generating the line contact, and this is line contact. Hence, it can be more load carrying capacity, and more rigid than this is more rigidity than the ball bearing, because ball bearing has line point contact, but this is line contact, hence more rigidity as compared to ball bearing. Okay, now I mean here also line contact due to the coefficient of friction is less, and less frictional loss as compared to sliding contact bearing, not compared to rolling contact bearing. Okay, now here, I mean here the disadvantages here is, I mean we can't go for the not self-aligning bearings. These are not self-aligning. We are going to discuss later self-aligning bearing, about self-aligning, how the self-aligning bearing can be designed. Those things we will discuss later. Okay, now this is the more noise will be generated, obviously, because this is only line point contact in roller bearing, I mean ball bearing, but sorry, ball bearing here point contact, but here the roller bearing line contact. Obviously it is going to be a more noise. We need a more lubricant also as compared to ball bearing. These are the disadvantages. Angular contact bearing, just now I told you this. You see this inner case and outer case. I mean there is some angle. In this angle the balls are fixed. This is angular contact bearing. The contact between the balls and races makes an angle, with the axis of the bearing, axis of the shaft. Okay, and this is the angle contact bearing. Now here hence the reaction, this is an angle contact bearing. Wherever angle is there, obviously it's going to be a two components. The force is going to be a two component, because the resultant component acting this angle. Then it will be resolved into two components, radial and axial thrust. Then the angle contact bearing subjected into radial and axial thrust. Okay. Now I come to this. Now, I mean, next one is, this is a self-aligning bearing. Self-aligning bearing. Anyway, the angle contact bearing, both, sorry, one was some few advantages I tell you that about the angle contact bearing. Load carrying capacity can be used, load carrying capacity in axial direction and radial direction. Hence, wherever axial load and radial load is possible, those places we can easily use this using this type of bearing, angular contact bearing. But this is a large load carrying capacity place also, we can use this type of bearing. Okay. Now the disadvantages, it must be mounted without axial plate, because that is important thing. So okay, this is the disadvantages. Now I come to this sliding self-aligning ball bearing. I mean, see here, the self-aligning ball bearing can be classified into two types. One is self-aligning ball bearing, self-aligning roller bearing. The self-aligning bearing can be classified into two types. One is self-aligning ball bearing, self-aligning roller bearing. Here we are using two rows of balls in the inner race. Okay. Now this, this inside this outer race, the balls are sliding. Sliding as well as self-aligned somewhere the shaft of the axis. Shaft axis may be not proper. there may be a slight or light alignment during power transmission. These bearings can be easily used and easily transmitted without any issues. This self-aligned in the inner trace of the outer casing. With this, now this is a self-aligning ball bearing. Instead of balls, if we replace roller, it is a self-aligning roller bearing. Okay, that's a roller bearing. Here, the self-aligning ball bearing consists of two balls. I mean, two rows of balls with roll in the common spherical surface of the outer race. In this outer race, okay. So in this case, assembly of the shaft inner race and the balls can gauge with the gauge can freely roll and adjust them itself during angular alignment. Okay. Now instead of balls, if you use roller rolls, I mean roller, then it will be a self-aligned roller bearing. Now where we are using this type of bearing, we are using in agriculture machinery and ventilators and railway axle boxes we are using. Now I come to the next one is spherical bearing. Now spherical bearing. Now the spherical bearing, sorry, first we, okay, spherical bearing, okay, spherical bearing. Instead of, now this is says this is also self-aligned bearing. Instead of balls, if you use this self-aligning roller bearing. Now I come to this taper roller bearing. In the taper roller bearing, see here, the taper roller bearing is the considered rolling element in the frustum of cone. I mean, if you extend this axis, this is a frustum of cone with respect to center of this shaft, center axis of this shaft. Okay. Okay. Now frustum of cone. Here, this is the axis of the individual rolling element. This individual, each rolling element to each rolling element, axis of the individual rolling element intersect in a common apex of the point is nothing but axis of the shaft or axis of the bearing. Okay, where we are using this kind of bearing? I mean, the rolling elements makes an angle. Hence, here the rollers going to this bearing going to be subjected into radial component as well as axial component. Axial component is nothing but a thrust component. Okay. Now, please go through that your book. You can get more information. This bearing, this taper bearing, can be used for heavy radial and axial loads, and this is a more rigidity. This a taper roller bearing is more rigidity as compared to ball, I mean ball bag deep groove bearing or this bearing, cylindrical bearing, cylindrical roller bearing. Okay, the disadvantages is only this is the more costly, this bearing. Another thing is that the roller bearing cannot tolerate misalignment. This also we cannot use for misalignment. We are going to have a separate type of bearings. I will show you later some video. Now the last one is the thrust ball bearing. I mean, the thrust ball bearing, whatever we discussed earlier, the position where the ball is positioned and how it was fixed, based on that, this is a we are classifying. This is a thrust ball bearing. The thrust ball bearing consists of two rows of ball. Here, this is a two rows of ball. I mean. Running between two rings. This is ring 1, this is the ring 2. This is running between two rings. The two rings is one is soft ring, one, I mean, this is called a soft ring, another one is housing ring. I mean, this is soft ring, this one is soft ring. Sorry, soft ring. This is housing ring. This top and bottom is housing ring. So the balls are rolled running in between the housing rings, in between the top and bottom housing rings. So this is the soft ring. The middle one is soft ring. So based on this design, we are saying that this is the thrust ball bearing. Now here, obviously this type of bearing, now the soft subjected to axial load. This is the axial load. It's only this, I mean, only thrust load. I mean, thrust load is nothing but axial load in only one direction. cannot be radial load. Here no radial load in this bearing. Okay, able to handle high thrust load, high thrust load, the high thrust load due to more number of balls. See here due to more number of balls, we able to use in high thrust load places. Wherever high thrust load design, that places we can use this type of bearing. Okay, now see here, this is whatever we discussed.
It's 11 o'clock.
Yeah, I stop it within 2 minutes. Okay, so now the last slide in today's class. Okay, this is self-aligning bearing. In the self-aligning bearing, the short, see here, the first figure, right? Now in the first figure, this is looks like a journal bearing only. The many applications, the bearing is required to tolerate the small amount of misalignment between the axis of the shaft and bearing. Axis of the shaft and bearing only. Axis of the shaft and bearing. The misalignment may be due to the deflection of the shaft under the load due to the tolerance of the individual component. Okay. Now this is a based on the figure here. Yeah, I completed within 2 minutes. The last thing once only we at least we complete types of bearing. Then next class we go for the depth. I mean depth about the bearing design concept. Okay. Now please give me please cooperate me because initially we are always starting 5 minutes or 6 minutes delayed. Okay, because of many students joined right time with me. Some students they are getting delayed because of their personal. Okay, so please cooperate. Just 2 minutes. Give me, I finish it. Okay, the shaft perfectly aligned in the, see here, the shaft perfectly aligned in the, so in the figure A. But when the shaft is deflected under load, the figure B now, the shaft is deflected under the load due to fluctuation of the load, then they exhaust the pressure on the edges of the bearing. See here, this is the edges going to be a more pressure, these edges of the bearings. When the more pressure created on the edge of the bearing, then what will happen? The edge pressure is so dangerous and may result in more wear and tear. Finally, it will may happen breakdown. Okay, right? Also the self-aligning bearing in the external surface of the bearing is made spherical shape. Now, this is the bush. Now we are using there's some external design inside this. Now this is the bush. Now this is our journal or shaft. Journal or shaft. Now therefore here the center of the spherical surface, this spherical surface, the center of the spherical surface at the center of the bearing. Now, therefore, the bush is free to free to roll, and free to roll in the seat and align itself with the journal. Then the arrangement made provide the lubricant between the spherical surface and bush, spherical surface and bush. Then any alignment going to happen in the shaft during the power transmission, this kind of edge pressure cannot be developed using this type of self-aligning bearing design. Okay, the principle of this is the principle of self-aligning bearing. So I will show you some video. I will share the video. Please go through that. These are the application. This is the self-aligning bearing. See here, we are using inside some, some spherical surface. Sorry, here this self-aligning bearing. Now see here, this is the cylindrical roller bearing we are using in. So even our cycle chain. Okay, then this is the spherical roller bearing. This is the needle roller bearing. Now tapered roller bearing. Okay, these are the types of bearings. So I stop it here. Please, if you have any doubt, please go ahead. Please, guys, please stay back. Now I stop it here, and I show you the video, because anyway you are going to have, I stop video, recording video. Okay, give me a the video maximum for 3 minutes only. I show the video. Please go through that. Just Immediately go through the video, you can easily understand whatever we have been discussed now. Just give me a 3 minutes. I show you the video. I stop the record now. Are you able to see my web page? Hello?
Yes, sir.
Yes, I stopped the recording video. Just see this.
The voice not audible, sir.
Yes, sir. It's not audible.
Not audible, huh? Oh, what is this? Sure. 1 minute.
Sir, instead share the video link, sir.
Yes, yes, yes. 1 minute. Why it's not video audible? 1 minute, 1 minute.
Audio not audible.
1 minute, 1 minute. Hello?
Your
I'll
voice
sir.
call
is
you later.
audible,
Please
but
call me later. I'm meeting.
Once check the system volume, sir.
Okay. Yeah, I mean, are you audible or not?
You are audible, sir, but the voice of the video is not audible.
Okay, I try. Otherwise, I will share you the video. Now you see that now. Is it audible? Is it audible?
No, sir, no, sir.
no, sir. Sir.
No. Okay, pa. Then I do one thing. I share the video. I share the link. Please go through that video. Okay, go through that link. You can get it.
Okay, sir.
Please, tomorrow before coming to the class, please see this video. That is they clearly explained with application and the types of bearing, types of roller bearing, types of rolling contact bearings. They clearly explained. Very useful video. Please go through that. Okay, guys. Tomorrow you are going to tomorrow you are going to have exam. In the exam, numerical also there. I already told you that. Kalyan, only 47 students are there. What about remaining students?
Sir, somebody
Hmm.
left, sir. On this no.
Okay. Tomorrow exam, some numericals also there. So
Yes, sir.
theory based questions. Theory based objective is very easy. Don't waste your time in the theory questions. Even the problems also maximum 1 minute enough. That's such a kind of problem only. Okay. So tomorrow evening you are going to exam. I'm putting reminder.
What's the exam time, sir?
Exam time. Okay. Do you have any lab till 4 or 4:30 tomorrow?
No,
So there
so
is a
we can keep after 6, sir. We can keep at 6.
Sure, 6, huh?
I
Okay.
will inform you. I will inform you by evening, sir. I will call you.
Okay. This evening?
Yes, sir.
Okay. Okay. So please prepare well. And I already posted the 3 assignments. Please submit
Yes,
in right time. And next we are going to have exam, right? So whatever
sir.
you are going to cover
Sir,
till
sir, we
coming.
have TZ, sir. 19 and 20 technology is going on, and some people are in association, sir. They have to conduct events.
Okay.
So, can we submit assignment 3 after mid, sir?
No, 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 no. It's not possible. It's not possible. I cannot accept. You asked me that extend the deadline. 2 times I extended the deadline. Now you are again asking no flexible because what is the
Actually,
use of
one
submission assignment after midsem? Because I mean, if you do well in the assignment and practice whatever we discuss the problem in the class, obviously it will helping you in the exam, right?
otherwise we will submit before exam, sir.
You have to submit it this week, pa. No, third assignment I gave the deadline Saturday. This assignment, this 2 assignment also I extended to Thursday. Then what we can do beyond this as a faculty? Okay, the number of questions also maximum 6 or 7 questions, right? So and we already posted the assignment in well in advance. Please understand and do it well. Even I can extend one more day also, but I cannot postpone to near the exam because you will not do. Many students will say that, sir, we have exam tomorrow, mid. Like that, they will deny. So I don't like. I'm not.
Okay.
This is not for my. I mean, what I'm going to get. You are going to get fruitful things, right? If you do well, you are going to get fruitful things. Please don't postpone the assignment submission at the near to the mid. You submit everything before this weekend. Very simple only. Okay, Kalyan?
Yes, sir. Okay,
Then
sir.
I am requesting all the students, please go ahead and submit the assignment before this weekend. Thank you, Pa.
Okay, sir.
Thank you, guys. Thank you, everyone. Meet tomorrow.
Yes, sir.